Welcome to EC Elimu Learning Simplified, and welcome to this lesson. In the previous lesson, we have looked at pressure in liquids, and we have seen the three factors which affect pressure in liquids as height, density, and gravitational field strength. Now, do you know that pressure generated by liquids can be transmitted from one point to another, since liquids and fluids can flow? That's what we are going to discuss in this lesson on Pascal's principle. My name is Albert. I hope you're enjoying the lesson. By the end of this lesson, I expect you to be able to state Pascal's principle, or the principle of transmission of pressure. Then demonstrate Pascal's principle. You're going to do a very simple setup which you can demonstrate how pressure is transmitted in fluids. And then finally, state and explain the applications of Pascal's principle. In the history of science and physics in particular, a man called Pascal realized that if you have a system, let me try to draw the system here, a system or containing a liquid, and the system can be of any shape. Let me draw any shape here. That is the system of any shape. It's enclosed within those lines that I've drawn, and this system contains a liquid, and this liquid is a uniform liquid. So if it has a liquid throughout this system, and then you have your piston here, if you push it with a force F, this piston with this cross-sectional area will cause a pressure here. So let's say it causes pressure 1. This pressure, you realize that it will be transmitted to all other parts of this system. Every part will receive the same pressure that it caused at that piston. So all parts of including this one, will receive the same pressure that was caused at one point. And then he came up with a law or a principle which states that pressure applied at one point, pressure applied at one part of a liquid is transmitted equally to all parts of the enclosed system. An enclosed system means this liquid must be in an enclosed part, or in a compartment where it cannot move out, and then there is no gap between this liquid. So that is what we call Pascal's principle, or the principle of transmission of pressure in liquids. Now, you can do a small experiment to demonstrate Pascal's principle. And what you do, you take a container of any shape and then make uniform holes throughout the container, put a liquid inside, and then cause some pressure by pressing the piston. What you will realize, the liquid will squirt out. The liquid, if you are using water, it will squirt out of the holes with equal forces. These holes, this liquid will move out with equal forces throughout the holes that you have. Now, this shows that pressure generated at this piston is transmitted to all holes throughout that container, and that one now confirms Pascal's principle. The principle of transmission of pressure in liquids, or what we call Pascal's principle, is applied in the working of what we call hydraulic machines. Hydraulic machines include hydraulic press. Hydraulic press, we are going to discuss it in the next few minutes, but simply this is a machine which is used to compress textile products like blankets, even mattresses. Remember, we have mattresses like high density mattress, low density mattress, and even medium density mattress. Now, the machine which is used to compress them into those distinct densities is called hydraulic press. Then we have hydraulic lift. Hydraulic lift is used to hoist cars in garages. Like, and you can see on the screen, we have a car which has been hoisted, and it has been hoisted using this machine we call hydraulic lift. Then finally, we have hydraulic brake system. This is used for braking in cars. Most cars that you know, they use hydraulic brake system. And by the way, have you ever heard of a brake fluid? Now, if you have ever heard about that, that is what we are going to use in the hydraulic brake system. Now, how do we determine the pressure transmitted in hydraulic machines? We are going to determine that, but first it's very important to note on what we discussed earlier under the factors affecting pressure in liquids, that pressure at the same level or same height is the same or is equal. So in this case, it means if you have a liquid like on the screen here, the liquid that you have has the same height on the left column, so it means P1, and then we have pressure on the other end, which we can call P2. Since they are on the same height, it means P1 is the same as P2. That is according to the note that we have here. Pressure at the same height is equal regardless of the shape of the container that we have. Then now, if we use Pascal's principle, let's look at the first piston on the left hand, which we have a small piston here, which we call S, and there is a force Fs which is acting on the small piston, and the small piston has an area which is As. If we want to calculate pressure of this at the small piston, which is caused on this liquid in touch with the small piston, which we are going to call pressure on the small piston, is equals to force on the small piston over area on the small piston, because we said pressure is equals to force over area in solids. Now the pressure which will be caused by that solid, which is a piston, will be transmitted or will be exerted on this liquid. Now this is the same as P1 from what we just brought up there. Then now, are we able to calculate pressure at the second piston, which we call the large piston? Pressure at large piston, because this piston, it has a force FL and area AL, then pressure at the large piston will be force of the large piston over area of the large piston. But now, from Pascal's principle, it says pressure exerted at one point of the fluid. So at small piston, this pressure caused by this piston will be exerted on this liquid here. It will be exerted on this liquid here, and then it will be transmitted equally to all parts of the system. So if you cause PS or pressure at the small piston here, the same pressure will be transmitted to the second piston, which is PL. So here it means PS is the same as PL. And from the note that we had there, P1 is equals to P2. Now this one has brought as some idea. Pressure at the same height is the same, but also at the same time, pressure exerted at one point is transmitted equally to the other parts of the system. Now, PS is calculated as Fs over As, and then PL is calculated as FL over AL. Now, since PS is the same as PL, then we will not be wrong by saying Fs over As is the same as FL over AL. So if I give you force on the small piston, I give you area on the small piston, and I give you area on the large piston, you should be able to calculate force on the large piston. So given three, either F1, Fs, As, Fl, and then you are told to calculate Al, you can be able to do that. Given Al, given Fl, given As, you can calculate Fs, and vice versa. And then of course, another important to note is that if you know the pressure at one point, if you know the pressure here, automatically it will be the same as the pressure on the other arm. So we are going to do few examples that will involve these equations we have wrote here. The first one is pressure on the small piston is equal to pressure on the large piston. Another one, force on the small piston over area on the small piston is equals to the force on the large piston divided by area on the large piston. So let's do an example and then we see what we have been discussing. And the question is the area of a large piston of a hydraulic press is 3 square meter. So here we have area on the large piston is equals to 3 square meter. and that one of the small piston is 0.5. So AS is equal to 0.5 square meter. Then we have a force of 100 newtons is applied on the smaller piston. We have Fs, which is 100 newtons, and then they are asking how much force is produced on the large piston. They want us to find Fl. So what you do, you use the equation that we have formed, that is Ps is equals to PL, which is the same as Fs over F over As is equals to Fl over Al. So do we have Fs? We have Fs as 100. Do we have As? Yes, we have as 0.5 square meter. Do we have Al? Yes, as 3 square meter. Now, do we have Fx or Fl? We don't have Fl. That's what we are looking for. Now, you can feed your values in this equation. Fs is 100 newtons over As is 0.5 square meter. Now will be equals to FL, which we don't know, over AL. Do we know AL? Yes, area on the large piston is 3 square meter. And then in this case, what do? We just cross multiply. Cross multiply like that. Then it will be 0.5 square meter times FL is equals to 100 newtons times 3 square meter. Then now to remain with FL on one side, then you divide by 0.5 square meter, divide by 0.55 square meter. Now this one will go, then we will remain with FL is equals to 100 newtons times 3, which is going to be 300 Newton square meter over 0.5 square meter. So in this case, square meter, we'll go with square meter, and then you will remain 300 divided by 0.5. This is the like 300 times half, which is the same as FL is equals to 3, not 3, but 6, which is the same as 600 newtons. So the force on the large piston is the same as 600 newtons. Now, are we able to confirm? Can we confirm if this one is true? Yes, we can confirm if that one is true by finding, because we have just said PS must be equals to PL. Now, can we calculate PS? PS is the same as force at the small piston over area on the small piston, which is going to be force on the small piston is 100 newtons, then area on the small piston is 0.5 square meter, 0.5 square meter. Now what are we going to get as our pressure here? It's going to be 100 newtons divided by 0.5, which is the same as 200 Newton per square meter. That is PS. Now, can we calculate PL? PL so that we see if they will be equal. PL, now we have our FL. FL, it will be FL over AL. FL is equals to 600 newtons, then AL is 3 square meter. Now, if we solve this one, it will be equals to PL will be equals to 600 divided by 3, 200 newtons per square meter. As you can see, P1 now, therefore, P1 is equals to P2. We have confirmed that. So what you do, you just substitute that equation and do your equation like that. And if you want to prove, you can use that principle. Pressure at the small piston is equal to the pressure on the large piston. Another example so that you can understand better, the question reads, the areas of the smaller and the larger pistons of an hydraulic press are, area of the smaller one is 6 square centimeter, area of the larger one is 520 square centimeter. Then calculate the force applied on the smaller piston. Fs is what we are looking for, which will be used to raise a rod of, so we have Fl, which will be 8,400 newtons. Now, to calculate Fs, you use our equation. Fs over As is equals to Fl over Al. Now, do we have Fs? No, that's what we are looking for. Over As, yes, we have 6 square centimeter, which is going to be Fl, yes, 8,400 newtons, over Al, which is 520 square centimeters. So what you do, you cross multiply, and then it will give you Fs times 520 square centimeter is equals to 6 square centimeter times 8,400 newton. Then what you do here, you divide 520 on both sides. You divide by 520 square centimeter, then you divide this by 520 square centimeters. And now 520 square centimeter will go this side, then on the other side centimeter or square centimeter will go with square centimeter, then we will remain with Fs is equals to 6 times 8,400 newtons over 520. And now this one is going to give us 6 times 8,400 is going to give us 50,400 newton over 520. Now our Fs will be 96.92 newtons. So the force which is required to raise the mass or the force of 8,400 will be 96.92 centimeters. No, so now I want you to use this idea of P1 is equals to P2. Use this force with this area. We use this small force with the small area. Find the pressure. See if it will be the same as force on the larger piston over area on the larger piston. That will be your assignment. You prove that. Now let's do the last question as we conclude our lesson. The question is, in an hydraulic machine, the pistons of two connected cylinders have a radius of 5 and 50 centimeters respectively. So we have a hydraulic machine which has cylindrical pistons. So they look like this. The smaller one has a radius of 5 centimeter. Then the larger one has a radius of 50 centimeters. Then the force on the smaller piston, the force here Fs is equals to 200 Newton. Then calculate the force on the larger piston. Now what you do, you have been given cylindrical shaped pistons. So what you do, you must first find the surface area of these cylindrical pistons. Surface area, remember we discussed it in measurements 1. And when you have a cylinder, the surface area of a cylinder is pi r squared. So now you have area on a small piston will be pi r squared, but in this case we are going to use the radius of the small cylinder, and then the area on the large piston will be pi r on the larger piston squared. So can we now calculate area on a smaller piston? Area on the small piston here, AS, is going to be 22 over 7 times radius is 5 squared times 5, which is going to give us 78.57. Let me use red so that we can distinguish them. So this is the smaller area of the smaller cylinder. And then now can we calculate the area of the larger cylinder? AL is equals to 22 over 7 times radius is 50 times 50, which is going to be AL, which is going to be 7,857.14 square centimeters. So now we have area on the larger piston and area on the smaller piston. Now we can use our equation F1 over, or Fs over As is equals to Fl over Al. Now, do we have Fs? Yes, which is 200 Newton. Area on the smaller piston? Yes, we have it as 78.57. Now, is equals to, do we have Fl? No, that's what we are looking for. Now, do we have Al? Yes, which is 7,857.14. And now what you do cross multiplication, where you are going to get FL times 78.57 square centimeter is equals to 200 times 7,857.14. Now our FL will be 200 newtons times 7,857.14, then you divide by 78.57 square centimeter. So now our FL is going to be 1,571,428 divided by 78.57, which is going to give us FL as 20,110.41 newtons. So in that case, the first thing you do, you calculate the surface area, and then now you use our normal equation here to calculate pressure, that is Pascal's principle. So that is the end of our lesson today. For more questions like this, visit ECLIMU, and you can see the website down there and find more questions and solutions on the same.